Hi, welcome to another Systems of Equation video. We're now going to turn our attention to how we find the intersection between graphs. And there are three videos to go through this. The first example we're going to look at is how to find the intersection between a straight line graph and a parabola. So here's example one. Find the intersection between these graphs. Y is equal to 2x subtract 1 and y is equal to, in brackets, x plus 3 times brackets x minus 2. Well, the first graph is just a straight line graph with a gradient of 2 and a y-intercept of -1. The second graph is a parabola that has roots at -3 and +2. And these two graphs intersect at these 2 points, 2 intersection points, and we're going to determine where the intersection points are. So let's get into how to do this. Because they are written in the form y equal to something, we're going to take the two somethings, the 2x minus 1, and put it equal to the x plus 3 times x minus 2. Doesn't matter which way around we put them equal. I've put the parabola first equal to the straight line graph. All right, well now we've got a bit of algebra to work through. So the first thing is let's expand out these brackets and simplify. So the minus 2x plus 3x simplifies down to plus 1x. We don't need to write the 1x. If you don't want to, you can just put plus x. Now we're going to take this 2x minus 1 and we're going to put them onto the left hand side with the other expressions. And we're going to, the 2x will become minus 2x and the minus 1 will become plus 1. And we're going to put it all equal to 0. So we're going to simplify this. We have plus 1x subtract 2x simplifies down to minus 1x or just minus x. And we have our minus 6 plus 1 gives us minus 5. Right, well now we've got this expression here, which is just a quadratic equation. X squared minus x minus 5 is equal to 0. That's what we're going to end up with when we solve systems of equations. Because one of the graphs is going to be a nonlinear function, we're going to end up with a quadratic. Now to solve quadratics, you need to put it equal to 0 like we've done. So we need to solve this equation. Here are our two solutions. Now if you don't remember how to solve quadratic equations, please go back and remind yourself how to use the quadratic formula by watching videos 3, 4 and 5. All right. Now we need to pick any of these graphs. I like to pick the easiest one, which is the y equal to 2x minus 1, the straight line graph. So I'm going to use y equal to 2x minus 1. What I'm going to do is I'm going to take my first x solution and substitute it into my x value for my y equal to 2x minus 1 rule. So I'm going to get y is equal to 2 times negative 1.79 to subtract 1. And that'll give me an answer of negative 4.58. So my coordinate for my first intersection point is the x value is negative 1.79 and my y value is negative 4.58. I'm going to do the same thing for my second x solution. I'm going to use the same equation, y equal to 2x minus 1, and use my second x solution, my second x up the top here, and I'm going to substitute that in to get y equal to 2 times 2.79 subtract 1 and work that out on my calculator. That gives me positive 4.58. So my coordinate for my second intersection point is my x value is 2.79 and my y value is 4.58. So what have I done with all this working? I've managed to find my two intersection points. So let me go back and bring up the graph once again. Here's my straight line graph, here's my parabola, and here's my two intersection points. My first intersection point is this point here at negative 1.79 comma negative 4.58. And my second intersection point is this point here at 2.79 comma 4.58. Right, well that's the process to find the intersection point between a straight line graph and a parabola. Work through the video again if you need to, or pause it and just look at all the work in here and go away and practice it until you're feeling confident. Thanks for watching.